Okay, good morning everyone, how are you guys? Yeah, okay, me too. Still slightly drunk from yesterday and sort of into that uncanny valley of hangover kicking in, plus loads of caffeine, which is going to make all of the live demo parts of this really hard as my fingers are shaking too much. I won't be able to use the mouse, all of that sort of stuff. So I apologize for that in advance. What else? My name is Harry. I have a Twitter handle which is HJWP. It's full of fascinating information. You must follow it. I work for a company called Python Anywhere. Who's heard of that? Yeah. Everybody, because I just mentioned it. Okay. A beta testing code is my website if you want to do testing stuff, but today's talk is about spreadsheets. Who loves spreadsheets? Okay, that's not a bad response for a room full of programmers, honestly. Okay, so how's this talk going to work? I want to take you back to 2005. It was a simpler time. Gmail was still invitation only. I was putting the finishing touches on my MySpace page. I was really pleased when DJ Shipmap friended me. Britney Spears had just released her seminal comeback album, Toxic. James Blunt was in the charts, and of course it was the beginning of the Canadian and North American ragga jungle renaissance, if you care about that. And a group of idealistic programmers thought maybe they could make a better spreadsheet. The concept was, what if you could use Excel and do all the cool Excel stuff, but you didn't have to use VBA? You had Python. Wouldn't that be loads better? Let's build that. So they did. I wasn't there. But I came along a few years later when they sort of rebuilt that, and we rebuilt together that whole product, which is called Resolver 1. Did anyone ever use that, Resolver 1? Okay, the developers of the software used it. One person over there, that's not bad. Which is a great fun tool, and I was lucky enough to join the company when we decided to re-implement that as a web application. That was a thing called Project Dirigible. Did anyone ever see that? One person, okay, yeah, well done. Another one of the developers of the application. So we built it as a web-based spreadsheet, and we ran it for a few years, and in the end we found that people were more interested in being able to run code in the cloud that was Python code, and they were not that interested in spreadsheets, and so that's why we made Python Anywhere, which is an online place for running code in the cloud. The cloud. Dirigible sort of floated around for a little while, and we've now sort of retired it, and instead open sourced the application. So the source code is up on GitHub, if you want to go and check it out. And what I thought I'd do today is give you a tour of that source code, because when Giles first explained to me how spreadsheets work, he did it in the pub, and he just said, I was like, I'm going to work for this spreadsheet company. How do they work? Like, surely it's massively complicated. And he goes, no, it's easy. And he showed me on the back of a napkin in the pub, and I thought it was quite exciting. So I'm going to try and recreate that for you guys, and there's a sort of like quite exciting way that Dirigible in particular works and does spreadsheet stuff that we're going to go through. So the talk's going to be basically little demos of the spreadsheet app, and then I'm going to explain using code examples how it all works, and we're going to try and build a spreadsheet from scratch. So, are you ready? Yeah. Okay. So what do you need for a spreadsheet? Okay, you're going to need a grid. I'm going to assume that the UI just works. Okay, so we're going to talk about the back end of a spreadsheet here. You're going to need a 2x2 grid, and you're going to be able to type some things in. So if I go 1, 2, and then like 3, like that, fine. That's a spreadsheet. Okay. So we're going to start by having some sort of representation for that. Like we need a sort of data structure and a way of holding that sort of a structure. And I'm going to say we're going to have a little worksheet object. It's going to have some keys keyed on row and column, and then we're going to represent cells somehow as the values of that worksheet. So far so good. Okay, but this doesn't really do anything. We want our spreadsheet to be able to do things. We want to be able to go into cells and type things like equals 1, shift plus 1. Oh, it works too. Okay, fantastic. So we'd like a spreadsheet to be able to do at least that, do a little bit of maths. So how could we do that? Well, we're going to start to build the simplest possible spreadsheet. We've now got a distinction between equals 1 plus 1, which is the formula in the cell, and the cell's value, which is the evaluation out, which is 2. So I'm going to build a little cell class. It's going to have a formula. It's going to have a value. I'm going to have a special undefined thing that's going to have properties like when you multiply it with something, it's going to give you an error or maybe give you 0, whatever. And then I'm going to have my first sort of implementation of the calculate loop. I'm going to run through all of the cells in the worksheet, and I'm going to say if they've got a formula, I'm going to call eval on it. That's just straight Python eval. And then if it's not got a formula, I'm just going to say the value is the formula. Okay? Okay so far? Any questions? So okay, now I can do any Python I want in a spreadsheet cell. So let's do some amazing Python. So let's go equals 1 plus a. All right, so I'm going to need to be able to do that, which is catch errors, right? And so that's pretty simple. I'm going to wrap my little code in a try except, and then I can populate a sort of new attribute of my cell, which is a dot error, and then I can display them nicely in the grid, and I've got a little sort of standard output there that says, oh, okay, you've made a mistake in that sort of formula. So far, we haven't got a spreadsheet yet, right? Because if you want to have a spreadsheet, you need to be able to put functions or formulas that refer to other cells. So I'm going to do A1 plus A2 over here. Ta-da! 3. Can we get a round of applause for that, huh? So, equals A1 plus A2. How's that going to work? So the first thing I'm going to need to do, yeah, okay, thanks, syntax highlighting, is I'm going to be able to, I'm calling eval on that thing, and A1 and A2 is not valid Python, right? So I've actually got a slightly different syntax from Python. I need to tack on the Excel syntax, right? I'm going to need to dereference the sort of A1 string and transform it into worksheet 1,1.value plus worksheet 1,2.value. So we're going to have a sort of a parser, basically. And I'm going to store, instead of like this sort of straight string formula, I'm going to read that, interpret it, and convert it to a Python formula. And that's going to happen in this little function here called get Python formula from parsed tree. I'm going to notice any syntax errors in there which I might raise like this. And then I'm going to make the formula property, so when you assign dot formula, it actually populates Python formula. Fine, and so I'm sure you're all dying to know how does this sort of recursive parser work, because of course it's going to involve recursion, which is the only fun thing about programming. So I'm going to show you the test first with that kind of company. So equals 1 should parse out to 1. Equals 1 plus 2 should parse out to 1 plus 2. And similarly, equals A1 should parse out to worksheet 1,1.value. And so those are our tests. And the way it works is you've got some sort of parser. It's going to call for each parse node. You're going to rewrite it. Rewrite is a sort of recursive call. And you go into each of the nodes. And then you've got some special cases with when you spot a cell reference, you're going to convert that into valid Python instead of the string A1. When you spot a cell range, you do cell ranges. And finally, there's a little bit of thing there where, because A1, the syntax for making a range in Excel is A1 colon A2, so colons have a special meaning in Excel, but they also have a special meaning in Python. So what we say is in the Python that you want to use in the spreadsheet, you use a special little arrow symbol instead. Okay, fantastic. But now the problem is I can't actually calculate equals A1 plus A2 until I've already evaluated A1 and A2. So I've now got dependencies in my spreadsheet, right? So while I'm doing that parsing, as well as just getting out a formula, I'm also going to store dependencies, and I'm going to be able to identify for each cell what do you depend on. And in order to now actually evaluate my spreadsheet, I'm going to need to go and build a dependency graph which says which cells depend on what and which ones do I have to start with. And I'm going to have to start with the leaves. Does that make sense? Okay. So we're going to do something like that. I'm going to have a calculate cell function. It's going to call eval, and then I'm going to have a load constants function that's going to go and find all of the worksheet items and find the ones that don't have an equals. It's going to populate all of them, so they're already ready. And then I'm going to build my graph. I'm going to call build dependency graph, and I'm going to get the leaves. I'm going to run through all of the leaves, pop them one by one, calculate that particular cell, and when I've calculated a cell, I know that it is no longer a dependency, so I can remove it from its parents' dependencies. And that's what this little remove from parents function does. And then that means once if I look at the parent and it actually has no more dependencies left, then I can put it onto the leaf queue, and that's going to be my sort of algorithm for processing that dependency graph, that tree. Does that make sense? Yeah. Okay. Is it all making sense? Oh my god, like you can actually see a spreadsheet might work. And then finally, what does build dependency graph look like? This is probably the hardest bit of code in the Dirigible spreadsheet. I've simplified it very slightly for you. But I now this graph needs to be able to tell you not just what the dependencies are, but it also needs to tell you what the parents are. So I need a two-way graph. So I'm going to run through all of the spreadsheets, and I know the individual dependencies of one cell. I need to turn that into a graph that maps children and parents. And so this is the thing that Giles explained to me on the back of a napkin one time. So we're going to have a recursive call. We're going to go and look at a cell. We're going to go and recurse in for all of its dependencies. I'm going to go and call the same function, generate cell subgraph. And that's going to track what the worksheet is. It's going to build up the graph. It's going to track the current location. And we're going to also have a little set called completed. So we don't want this to go forever, and you might be able to visit a cell twice, and if you spot that it's already been done, that's going to be your exit from the recursion loop, right? So if location is completed, we exit. Otherwise, we recurse into the next cell. And then we add them to this sort of completed thing at the end. So the last thing to say is this is the bit where you actually build the graph. So if the location is not already in the graph, we're going to add it. At some point I should speak a little slower. What do you think? No, faster? Yeah, okay, fine. All right, so I'm going to add the location to the graph if it's not already there. I add its children, and I add sort of the parents, and that's how you go there. So can you spot any problems with this so far? What is the problem? Well, let's have a look. Do circles work? Well, I've got equals A1 plus A2. What if I go equals, let's see, B, let's try them out, B2. Okay, and that's nothing, and I'm going to go equals A, actually, no, B2, B4 is what I wanted. Equals A. What's going to happen? Aha! It has caught the cycles. How are we going to do that? Well, this is where the little recursive hell really starts. You're going to have to run through and track not just the worksheet and the graph and your current location, but you're also going to track the path. So where have I visited in this particular tracking of the graph so far? And I say, if I spot myself that I'm already in the path that I've tracked so far, then that is a cycle error. I'm going to raise that error inside my little function. And what that means is that when I call it recursively, I also need a try except that's going to catch any cycles from the children of the thing that you're looking at, and it's going to assign it as an error and also mark that I implicitly am also in a cycle error. And at this point you need a lot of tests or your brain melts. But you can pretty much conceptualize that that is a possible thing, and I've actually demonstrated it. So my objective here is that by the end of this talk I'm going to un-open source Dirigible, and you guys should all be able to re-implement it. So I'll give you about 2 weeks to do it, yeah? All right, so here's the real fun. Okay, so we're well done. We've built a spreadsheet. It's less good than Excel. So how do we actually add some value here? We're going to want to start being able to write Python code. Notice that you can already put like any arbitrary Python into cells, which is quite exciting and certainly better than Excel. But really, we're going to want some sort of custom function. So what have we got? Gosh, fingers wobbly. Right. Oh, damn you. Bad sheet. Fantastic. All right, so let's see. I'm going to put a function foo. I'm going to go user code panel on the right. It's going to have syntax highlighting. Hooray! I'm going to do like return. What am I going to say? Return something times 3. Hooray! Save that. And then in a cell over here, I'm going to go equals foo of 3. And that's going to go 9. Hooray! What if I want to go equals foo of A1? Okay, so now if I want to call things like that equals foo of A1, then I'm going to need to only execute this, or only sort of have this function defined once I've already loaded the constants. So let's look at what the code for that might be. Back to this guy. All right, so I'm going to build up a little context dictionary, because so far I've just been calling eval on arbitrary code that the user's entered in, and that might be polluting my global scope, right? So the second argument to eval that you can pass in is a context. That's a little dictionary that's going to represent basically the namespace that eval call goes into. I'm going to pass in the worksheet so that we can refer to the worksheet cells. I'm going to call eval like that, and before I eval each of the cells, I'm going to just eval the user code that the user's inputted. Does that all make sense? All right, but what about that load constants thing that I was going to say? We're actually going to call load constants first, then we're going to build our context up. Well, I put load constants in there twice. That's just a deliberate mistake for you guys to spot. So I'm going to call eval on the user code in the context, and then I'm going to call evaluate formulae. So now I have my load constants function. I have my evaluate formulae. The evaluate formulae is the thing that builds the dependency graph and goes through each of the cells and calculates them. All right? Okay, so far. All right, so that's all very well. I can now write arbitrary functions, I can use them in cells, and those functions can access any constants that there might be in the cells. But what if I want to write an arbitrary function that can, let's see which ones, that can also access the results of calculations, right? I wanted to be able to go not just equals A1, which is a thing that's a constant, but I want to be able to access, we've got to do it, damn, otherwise you won't believe it really happens, right? Equals A1, shift plus A3, 2, and so if in here I'm going to do Did that not work? No, great. No, it's fine. Anyway, you'll believe me. So I'm going to be able to build some user code that's going to be able to access the actual results. So I need to be able to evaluate that user code after I've done my evaluate formulae. So at this point, the thing to do is just say, okay, well, we'll give the users two little code boxes. One that they can run code before we sort of evaluate formulae, and one that they can run code after we evaluate the formulae. And I think I've got a demo of this somewhere here. Somewhere here. Yeah, that's right. So you could, anyway, that all works. And I'll show you the code for that. All right, fine. So now my whole calculate function has got two arguments. I've got the worksheet, I've got the user code pre-formula eval, and I've got the user code post-formula eval, and I'm calling these two eval statements. So I can now do all sorts of magical things, notice. So in the pre-formula eval, I can now actually write code that populates the formula in the graph. So I can actually write some custom code that assigns to cell.formula, and so I can have programmatically generated formulae in my spreadsheet. I can do things like I can make the value of a cell be a class or a function, and I can call equals A1 of A2, so the value of A1 can be a function. That's quite fun, can't do that in Excel. And I can programmatically generate formulae and all sorts of fun. But one of the things that occurred to us now is if you look at basically how our code's working here, we do load constants, eval pre-formula, evaluate the formulae, eval post-formula. We can actually do something quite a lot cooler. So what I want to show you is what the actual user code panel that we present to users is. And it looks like this. Oh, that's the wrong one. There we go. That's great. Come on. This is the actual user code panel that a user sees when they log into Dirigible. We pre-populate a bit of code in there, and there's a function in there called load constants. And there's a function in there called evaluate formulae. And what that code actually looks like in the calculation loop is this. We call load constants. Oh, no, we don't. We build up our context. Blah, blah, blah. That's just a repetition of what we had before. Here. We've got load constants. We've got evaluate formulae. We've got our calculate loop. I'm going to build up a context dictionary that contains the worksheet, and load constants is the actual load constants function. Evaluate formulae is the actual evaluate formulae function with the context curried in, and undefined is there. And the calculation of the spreadsheet is exec the user's user code, which contains the functions that recalculate the spreadsheet. So the user code is the spreadsheet. Thank you very much. So that's a neat trick, but what it means you can do is all sorts of crazy stuff, like since the user actually has access to the evaluate formulae call, the user can really hack up their spreadsheet and do all sorts of crazy things. So somewhere in here is a retirement calculator, which is Giles's favorite demo, and the user code for this can do things like this. I can do goal seeking, right? Have you guys use goal seeking in Excel? You know what that is? It's like you build some functions in Excel and they come up with the wrong answer, and you tell Excel, right, here is the answer that I actually want. Now reverse engineer all the values that I've put in until it all comes out right. And you can actually do that in Dirigible. You can call evaluate formula in a little loop, and you can tell the spreadsheet to keep evaluating itself and reassigning the formula and changing itself right there in the user code. So you've got fully the opportunity to make the most twisted spreadsheets imaginable, but you can also unit test your spreadsheet. So that's pretty much the end of the talk. I hope you enjoyed that. Thank you very much. So how's our time for questions? Oh, good. Any questions about that? Let me show you the GitHub URL for this particular thing, because I'm sure you guys are all desperate to go and look at the real source code. Some things I skipped out include the fact that you can actually parallelize the recalculation. So once you've built a dependency graph, you can evaluate individual cells in different threads. We started building it so you can actually evaluate on different machines. So different servers could actually recalculate different parts of the graph and pass them around as JSON. So there's all sorts of horrible threading code, which I haven't left in there. Obviously, you might need some sort of security because you've let the user use all of Python and it's going to run on your servers. So we did used to have security. I've ripped that out of the Dirigible code base for you guys for simplicity. So I encourage you to put it on your own servers and make them available on the public internet. There we go. And so the URL there is github.com, Python Anywhere / Dirigible spreadsheet. So yeah, questions? Marc-Andre. We can just stand right next to each other. What is your question, Mark?
My question is this, I mean, you just showed the web interface. Is it also usable without the web interface?
Okay. Could you use it without the web interface? I can have a sort of slightly tangential answer to that. Yes, so what we did, we started building an API for it, so that your spreadsheet, with a sort of public key type of infrastructure, you can actually call your spreadsheet as an API and get functions back. And then a really sexy thing that you can do is that once you've defined a worksheet that does some calculations, we made a function called run worksheet, which will let you from one spreadsheet call another spreadsheet. And what you pass into it is any values you want to modify, like sort of inputs, so change cell A1 to this, cell A2 to that, and then pull out the value of cell D76. So one set of massive complicated calculations can happen in one tab, and then you can call that in another tab, and again you can do magic like parallelize that stuff. So yes, APIs and spreadsheet as a function are entirely things you can do. I mean, okay, so it's lots of fun, it's really cool, but the fundamental problem with this is that in real life, you would never use this. You're going to use pandas in IPython notebook, aren't you? And that's absolutely right. So this is just a curiosity, but anyone that wants to run it and have a play with it should, because it's a nice thing to play with. Questions? There was more. Hello, Ian.
Presumably the finance industry would find this interesting. Did they? And what have you learned from those conversations?
Yeah, would the finance industry find this interesting? I think the original idea of Resolver 1 was to try and sell it to banks. And they found two things. Banks are very suspicious of small companies. They like to buy from big companies. Also, people who use Excel a lot get very used to Excel, and asking them to switch to a different tool is quite hard. And if instead you just go, well, we'll just implement all the features of Excel, then you've got into the game of trying to, actually compete as a sort of four-man team with Microsoft's, whole UI team and 20 years of history. So I think probably if you wanted to do something like this and sort of put it out there for real people to use, the way to redo it would be to build it probably as a plugin for Excel or some kind of add-on for Excel itself. So people who will have their keyboard shortcuts and all their blah blah blah, and so they don't feel like they're leaving their tool, but they all get the niceness of Python and the extra flexibility. Sorry?
That's already available.
Yeah, there is a sort of plugin for Excel or for, is it only for the LibreOffice?
No, there's something you can plug in Python and Excel and write your thing in Python.
Yeah.
Windows only though.
Yeah.
The three Excel and Linux users are not really relevant.
I mean, so there's loads of other fun things you can do, like you could have special formula syntax that lets you evaluate whole columns and all sorts of things that are very hard to do in Excel you can make quite easy in this, which I think a simple plugin that lets you just write functions in Python for Excel won't quite get to. Yes, sir?
Have you got any facility to export to Excel or CSV so you can do your own code in Python and send the client an Excel file?
Yeah, absolutely, yeah. I mean, like I say, I'm not trying to sell this, it's just a curiosity, but one of the first things they did was import from CSV, import from Excel, and then export to CSV, export to Excel. There's good libraries in Python for doing that, XLRD, XLW something, and the other one. Yep.
What's the persist state? What did it persist to naturally?
Oh yeah, good question. So we store the worksheets as JSON. So because all we need to store is the formulae, basically, and the user code. So the worksheets data structure that I showed you there, that dictionary, you can basically call to JSON to that. And it's just keys, row column, values is the formula, and then a little other attribute is the user code, and that's your lot. Yep.
You mentioned you have some parser there. How did you generate a parser to do those things?
Wow. So I wasn't part of the team when the parser was there, but a lot of people that are considerably smarter than I am, such as Jonathan, presumably build the parser and all the complicated Excel grammar interpretation stuff. Yeah, you'll notice I glossed over that quite a lot. I've never understood that code, actually, but it does work.
So the cool thing about it is we ripped out the part, obviously, the C-Python part, and it's
Yeah, the cool thing about that is we ripped out the CPython parser rules themselves and added some extra cell notation rules to them. So it's like it is Python syntax with some additions.
Yeah, presumably some replacements as well for the little colon arrow thing. Yeah. Fine. Anybody know anything about parsers? If you want to get like interested in that, it's all up there. It's all open source. Hello. Over here. Well, I know Tom, so I'm not going to take him. Yeah. Did we try and build the dependency graph by just evaluating the formula and... Oh, I see. Yeah, what, sort of, by sort of putting some kind of listener on the objects that it accesses? Yeah, you could do that, I guess. Yeah, I mean, so once you've done all the hard work of parsing, you've already done all the work of identifying what is a dependency, and you've already done the hard work of like transforming a thing that says A1 into a thing that says worksheet row column dot value. So it seems like little extra effort to just nail them down at that point rather than evaluate them. Unless you can think of any other reason you might want to do the evaluation first type of thing. Just an idea. Yeah, cool. Tom? It's pythonanywhere.co.uk. Oh wait, no, you're right. Okay, it's pythonanywhere.com. That's where I work, www.pythonanywhere.com. If you guys don't have accounts on Python Anywhere, you absolutely should. Because like, what self-respecting Python developer wouldn't have an account on pythonanywhere.com? It is free. There's free web hosting. You can do all sorts of code in the cloud. You can max out 100% CPU on all our servers, and we find it quite hard to stop you. Any other questions? Yes, sir.
Can you get circular spreadsheets as well?
Circular spreadsheets. So you can have, when you build a dependency graph, it's not a single graph with one root. It's actually several different trees that are all isolated from each other. So you might have one tree that ends up in a circular dependency that therefore just dies, but all of the other parts of the spreadsheet can calculate fine. Sorry? Well, once you've got a circular dependency, you can't get to the bottom of it, so there's nothing you can evaluate. Interesting. That's interesting. Yeah. That's interesting. Why don't you fork it and see if you can get it working? That would be kind of cool, because you're right, like a cell's value is kind of it could be a function, so maybe, I don't know, something. I think it'd be hard to find exit conditions. Anyway, yeah, definitely fork it and make it happen. I think that'd be a great project to present to the world. Yep. Over there.
As it is right now, does it support multiple sheets in one worksheet?
No, but as I say, you can use the run worksheet function to call any sheet from another sheet. But there's no syntax within a spreadsheet to refer to another spreadsheet, another sheet's cells. So our model is the worksheet rather than the workbook. That's the difference with Excel. Yeah. Anything else? What else? Maybe I should ask you guys questions. What do you think? Like, was that more or less how you thought a spreadsheet was going to work? Was it more or less complicated than you thought? Hands up who's like, that's way more complicated than I thought. Hands up who's like, that's way less complicated than I thought. That's sort of what I was hoping for. Hands up who thinks that I should do this talk again ever. Okay, so program committees of any conferences I might have applied to recently, that was like 90% of the room suggesting that I do this again. All right, good. Thanks very much, everyone. Fine, yes. And an obligatory plug right here. This is an amazing book called High Performance Python. This is a much less good book called Test-Driven Development with Python. Both of these books and their authors, who are going to be here, signing them at about 1:30 today and giving them away for free. So that's free. You can have them for free. They'll be right here. Possibly even a third fun Python book about testing. All the books that we give you will stand up. These books are demo copies. And that will be at 1:30. Thanks very much. Thanks again.